Okay, welcome to part 2 of our Chapter 14 review for our midterm in our Online Foundations of Math 2 class at Amarillo College. I'm Sherri Clowe again, and we're going to continue on with our example problems. Use your permutation or combination formulas and notation to find the number of permutations of 12 objects taken 5 at a time. I'm going to use this opportunity to teach you a shortcut that I know. Here's the formula for doing this problem. We're going to do the permutation of 12 objects taken 5 at a time. Now if we use our formula, we're going to do a fraction of 12 factorial divided by 12 minus 5 factorial. That would be 12 factorial divided by 7 factorial, which is 12 times 11 times 10 times 9 times 8 times 7 factorial over 7 factorial. And since all of this is multiplied, we can divide out 7 factorial over 7 factorial, just leaving us 12 times 11 times 10 times 9 times 8. This answer can be achieved on your calculator. Which was 95,040. Now, I'm going to teach you a shortcut. Notice that right here, this is going to occur every time. You're going to be able to divide out this denominator with this every time. So here's what I would suggest that you look at. There are 5 numbers here, and you begin them with 12. So instead of using the formula, I do a shortcut for the permutation of 12 objects taken 5 at a time. I make 5 blanks, number of blanks will be 5. 1, 2, 3, 4, 5. And I begin filling those in with 12. Use this number used to start filling in the blanks. 12, 11, 10, 9, 8. Every time you'll get the same answer of 95,040 when you use your shortcut. Now the reason I like to use that shortcut is because we're going to need to use the permutation of n things taken r at a time in our combination formula. So that's why I like to use the shortcut, because it's really going to be helpful when we have to do the combination problem. The combination of 9 objects taken 4 at a time using this formula is going to equal the permutation of 9 objects taken 4 at a time over 4 factorial. Well, that becomes easy whenever you know the shortcut for the permutations. The permutation of 9 objects 4 at a time is we're going to make 4 blanks. 1, 2, 3, 4 blanks. We're going to start filling them in with a 9. So it's 9, 8, 7, 6 over 4 factorial. Okay, 2 times 4 is 8. 3 goes into 6 twice. My final answer will equal 9 times 1 times 7 times 2. Let's see, 9 times 7 times 2. 126. That is how I do my permutation and combination formulas. I try to make it as easy as possible. Okay, your biking club has 10 members. In how many ways can the club choose a team captain and a team treasurer? I know that this is going to be the permutation of 10 taken 2 at a time, because these are rankings, or having a team captain and a team treasurer are 2 different positions. And if, let's say, John is my team captain and Barbie is my team treasurer, that would be different from Barbie being my team captain and John being my team treasurer. So order does matter here. That's why it's a permutation of 10 things taken at a time. So we're going to have 2 blanks starting with 10 and then going down to 9. The answer is there are 90 different ways that our club can choose a team captain or team treasurer when we have 10 members. Okay, how many ways can the club choose 3 members to send to a biking competition? If we're just sending a group of people to a competition, it's just a combination because it doesn't matter what order we send them in. So it's the combination of 10 members taken 3 at a time. So that's going to be the permutation of 10 members taken 3 at a time over 3 factorial. Make 3 blanks. Start filling in with 10 and over 3, 2, 1. Let's see, 3 goes into 9 3 times, 2 goes into 8 4 times. This will be 12 times 10, which is 120 ways. Okay. How many ways can all 10 members line up for a picture? Well, that's going to be a permutation because you would have to change order for it to be a different picture. So the permutation of 10 members taken 10 at a time is 10 factorial, which is a really big number. I'm going to do that on my calculator. Go over to probability, down to the exclamation mark. 10 factorial is a really big number. 3,628,800. All right, 2 dice are thrown. What are the odds in favor of getting a total score of 10? There are 3 10s. So it's going to be 3 versus, this is how many ways you can get a 10 right here. This is going to be the number of ways that you cannot get a 10. Since there's 36 total, 36 minus 3 is 33. So there are 33 ways to not get a 10. Not 10. This is number of ways to get a 10. And you need to reduce this. It'll be 1,11. Okay. What are the odds against getting a total score of 10? You reverse this. 33,3, 11 versus 1 when you reduce it. What is the probability? Now that's a fraction. Okay, so of getting a total score of 10. 3 divided by 36, which is 1/12. That's how you report probability. Okay. A game is considered to be fair if its expected value equals 0. What is the expected value of this following game? For $3, a player is going to roll a pair of dice. So here's our sample space for rolling a pair of dice. If the player rolls a total of 7, the player wins $10. If the player rolls any other number other than 7, the player loses the game and gets no money at all. Is this a fair game? The way you calculate expected value is you take the value of a win and add it to the value of your loss, and you see if that's equal, therefore 0. So the value of a win is calculated as how much money you get if you win, and you multiply that times the probability of your win. Then we're going to add that to the money you spend if you lose, times the probability of losing. So that's the probability of the win. Okay, let's think about how much money you get if you win. You have spent $3, so that's minus 3, but you get a total of $10 if you win. So 10 minus 3 gives you a aggregate or a net worth of $7 if you win this game. The probability of winning depends on how likely it is for you to roll a 7. 1, 2, 3, 4, 5. There's 6 of those, so 6 over 36 is your probability of rolling a 7. Now, let's add that to the amount of money if you lose. If you lose, you get 0 money, and you have spent $3 to play this game, so you're negative $3 in the hole if you lose. You're going to multiply that times the probability of losing, which is, okay, if there's 6 sevens, that means there's 36 minus, there's 30 other numbers. Okay, so I'm going to multiply 7 over 1 times 6 over 30. 7 times 6 is 42 over 36, plus negative 3 times 30. This is over a 1. This is negative 90 over 36. And we're going to add these together and see if those equal 0. 42 plus a negative 90, that is not going to be 0. So, negative 90 plus 42 Negative 48 over 36. Oh, that is really not 0. So what that means is no, this game is not fair. Not a fair game. In fact, you can plan on losing money if you play this game. So don't play this game. A negative value, a negative expected value means that this game is weighted in favor of the house. In other words, you are going to lose money if you play this game, if it has a negative expected value, so don't play it. All right, that's all I've got for you. I hope this is very helpful to you as you prepare for your midterm exam. Bye.